high energy here, and this is low energy at this end. So this is a spectrum. It's a spectrum of low to high energy, and a spectrum of colors which indicate that type of energy. So you're going to be looking at various things happening. So the fact that we get, in the case of, in this particular case, we get a color that has a little bit of blue, a little bit of violet in it. What is violet? Violet is actually a high energy, and the yellow would be a medium energy. So you have, if you looked at this using the proper instrumentation, you would actually see a yellow line and a violet line. See two lines, okay? In the case of hydrogen, hydrogen gives a, we'll have to look at hydrogen later on, hydrogen gives a pink line. I wonder what pink consists of. Pink must probably be mainly red, and then if you look at the pink, you probably have a little bit of a bluish color to it, so there's a little bit of blue, all right? And when you look at it through the instrument, you're going to actually see a red line and a blue line and some other things, but basically you'll see the fingerprint. You see a fingerprint of the electrons that jumped up and returned, jumped up and returned. Some of them jump higher than others. Now, in the case of hydrogen, hydrogen is one proton and one shell with one electron. Well, that one electron actually jumps up. Where does it jump up to? It jumps up to these unoccupied shells. They have no electrons in them, but they exist. Whether you know it or not, they exist. That will jump up and find the shell and reside there for an instant and then come back down again. So hydrogen and helium, we're going to look at those two today using the electricity as a source. And we'll look at several of these using the flame as a source. So let's do another one here. This would be get rid of the color pretty much. So we'll go to this is calcium. Calcium is pretty quick. You're going to make sure you have a little bubble in there. And there's calcium. All right. It's very fast. You have to be pretty quick at it. What color is calcium? Red orange. Kind of a reddish orange. Now, if I did strontium, which is another metal very similar to this, I get a cherry red color. And I don't have that present at the moment. So that would be calcium. And we'll do copper. Yeah, copper is green, but the flame test for copper. This is very easy to identify. Just look at the color and say, well, it's probably copper. You know? But let's just try it. See what happens. Nice green color. So it's kind of the same color as this, all right? So where's green over here on the chart behind me?
And right in the middle.
Green is kind of a middle. All right, so if I take a special instrument and read the color that comes from the flame, I'll probably see a line right here with a great deal of the green, a little bit of the yellow, and a little bit of the blue. So that's the combination that you're looking at for copper. Now we'll look at sodium. Copper is hard to get rid of. See, it doesn't want to disappear. Copper.
But that's why they use it in so much, like, tools, right?
What's that?
Like, power tools, like the welding and
Copper's used in, or in the wires that are in your home. You'll see lots of copper in the wires. And copper is a wonderful conductor of electricity because it has electrons that are pretty mobile. Mobile meaning they move around a great deal. So it's a little bit better, not great. Lots of contamination with copper. So now we'll do sodium, see what sodium looks like. See the bright yellow flame from sodium? Sodium is present in most everything we touch. If you were to touch this with your fingers, you'd actually transfer sodium from your sweat glands onto that and you use the bright yellow color. So the bright yellow color is going to stay for a long time. Sodium is very persistent, see? It even hides the green color that we saw before. Sodium, you can't get rid of the sodium, that's why I did it last. So when you're doing your tests, you'll be doing sodium at the end, all right? We'll do sodium last. Now, where was sodium on this chart here? Sodium gave that orange, a bright yellow-orange flame, so sodium sits right here. I'm sorry, between the orange and the yellow. In fact, sodium is kind of neat in there because it has a single line, one single line. It's a very pure color.
Like in the middle of the orange.
It's between the orange and yellow. It's closer to the orange than it is to the yellow. So now, what you guys are going to do, there's two parts to this experiment. The first part of the experiment is we're going to look at the colors that are emitted by electrical current through a gas. The gas is going to be helium or hydrogen, two gases. We'll pass an electric current through those, and you're going to be able to determine what the nature of that light is. One's pink, and the other's kind of a yellowish, a pale yellow light. And you'll be able to look at the difference between helium and hydrogen. So those devices there on that desk will be used by the whole class. You have to kind of take your turn. It might take a little bit of practice to learn how to use them. The key is don't touch the instrument, not because it can break. They're very, very durable. It's because they're focused on a very, very intense beam of light, and we don't want to move it. If you move it, then you lose the beam of light. We'll have to reset it for you. It's not critical, but just try not to touch the instrument. Put your eye up to the eyepiece, and in the eyepiece, if you look into the eyepiece, you're going to see a big black screen, all right? On this side of the screen, you're going to see what looks like a ruler. It's a microscopic ruler. You're going to see a ruler here. On this side of the screen, you're going to see a single line. The single line will be a pink line for hydrogen or a pale yellow line for helium. That just tells you that you're focused properly. It's called a focusing line, all right? We're not going to worry about that. Just make sure that you see a line. If you don't see a line here, you're not going to see anything here either, all right? Now, what is this? This is actually a spectrum. What you're doing is you're looking at the light as it passes through a prism. The prism is going to break up the color of the light coming in. It's going to break up the color. So here comes the light from this tube. This tube is lit, and the light is going to be shining on this prism. All right. The light is then going to collect and is going to then be reflected upward in different angles depending on the light itself. All right. So you may get 1, 2, 3, 4. It'll separate the light into its various colors. All right. And these lights are then projected onto the screen, and the screen has numbers on it. Now, the numbers on there, I'm not going to tell you what they are. You're going to look at the numbers and look at them yourself. Some of the numbers are going to say, for example, some of them are going to say, one of the numbers is 6,000, all right? We're not going to take the last zero. We're only going to look at the first three numbers, all right? Some of them, I don't know which instrument's there, some of them might, in fact, that same number might be 600 here. Then this is okay. So some of the scales are measured in the European version and some of them in the US version. We're going to take the US version, which is simply 3 digits, right? Got that? So forget about the last number. If you look in there and see a 6,000 or a 5,000, it's 500 or it's 600, right? Now, you will see in here, you're going to see, for example, a line here, which might be a blue line. You might see over here a yellow line. You might see here a red line. That means that the colors that are being emitted by the lights are, in fact, broken into 3 pieces, into 3 parts, all right? You can then verify, though. You'll write down the numbers in your report, and the numbers will be indicated by the scale. You'll write down your numbers in the report according to the report sheet that's given to you in the textbook, not the textbook, the lab book. And then you'll check those numbers against the little picture in the back of the room there, which shows you the spectrum for hydrogen and helium. Now the difference is, it depends upon who manufactures the instruments and who manufactures that chart. The difference is that the scales are reversed. So if you look at that scale, the high numbers are on the, we normally write this here, you know, left to right. So the low numbers are on the left and the high numbers are on the right. That chart on the back wall is the reverse, right? It's 3, 2, 1. It's back, it's not 3, 2, 1, the right, like 700, 500, etc. It goes down the other way. So just make sure that you understand that the charts are going to be reversed. The only reason why you want to look at that chart is to make sure that you see in the device, in the instrument, the same results as published by scientists throughout the world.